Okay, so I'm going to talk a little bit about optimization or constraint-based modeling. And to do that, I'm going to use a simple example, something like we talked about with Sutherland Sketchpad. So how you could potentially set a set of constraints that were maintained and still use that within a design scenario. So if you remember that example, he started with a curve, and we'll use a polyline. That wasn't exact. We'll bring that in to Grasshopper. Okay, so what he was doing was setting up a couple of constraints so that even though he was drawing this by hand, it was allowing it to sort of maintain certain characteristics that he wanted to have. So he was setting up some rules about angles and how those could be maintained even though the geometry could be changed. So let's start by doing that. So in case of this, we want to set these angles to stay to the 90. No matter what we do to it, those shouldn't change. So we're going to explode this curve so that we can get our individual segments. And then we'll use some constraints in Kangaroo to be able to set those angles more specifically. So one thing that we want to do is we'll take those segments and we'll come up here to the angle constraint. So what that does is it takes two lines and sets an angle between them to a specific number. So in this case, we can take our segments. We'll say the segments will be plugged into A, and then we'll shift this list by 1 so we can get the next line, and that'll get plugged into B. And then we'll set the rest angle to be 90 degrees, but this is in radians. So we'll convert that to radians. And then we'll give it, I don't know, like strength of like 1,000. So that's our first constraint. So let's plug that into our goals. Turn these off. And then I'll show just that curve. Let's put a button on that so we can get it to reset. So now we can see that this geometry is now at 90 degrees. Let's just double check that with some dimensions. Let's take an angular dimension. We can, the same way we were doing before, we can explode this curve. We can use first angle direction and the second angle direction as our segments, basically. Oh, sorry, it's gonna want points. So let's use, instead of these segments, just use our vertices. And I'll shift this one one as well. And then we can use, what we actually need is the center point and two other points. So I'm going to shift this one by -1 as well. We'll set this one to the center point and this one to one side. So what this is for each of these points, shifting one will get one direction, shifting the other way will get the other direction. And you can see our angular dimensions are all set to 90. Okay, great. So let's add a couple more possible constraints that we can use. Let's say we want to maintain the area. So we can look at a polygon area. We'll use our polygon. Maybe we'll see what this area is already. So it's around 1,000. Let's go ahead and set it to 1,000. Plug this in as a constraint. And then we can also show that so area of it is 1,000. Each of these angles are 90 degrees. So we have some control over that. Now, one thing, we're looking at it in top view, but if we were looking at it in a perspective view, it could potentially be at 90 degrees, but not planar. Now, right now, it's not doing that, but if I were to move one of these points, it could potentially come off of that plane in a way that it could still maintain those constraints, but not a planar shape. So let's see if we can do that. Kangaroo has a nice sort of ability to sort of grab and move grasshopper geometry that other processes don't allow. So I can't pick this, but if I turn this on as a constraint and plug this in, scroll over that, it says you can drag your particles around. And to do this, you hold down the Alt key, your left mouse button, and you should be able to move things around. So you can see this is now out of plane. All the lines are still 90 degrees to each other, but not planar. So let's keep that in case we want to move things around in the future, but we'll set a planar constraint. So we'll actually say on plane, we want to take all of these vertices and say stick to the XY plane. So if we add that, now it won't move around, or at least it won't go out of plane. We can still move it around. and it'll try to maintain that. So let's go back to our top view. See that we have some ability to move these around while always maintaining that as 1,000, and these are at 90 degrees. Now, one other thing we might want to do right now, there's nothing holding this in place. We could set up a single sort of anchor point. Let's try to clean this up for you a little bit so you can see what's going on. We can set up a single anchor point. Maybe we just pick one of these vertices. We'll set that as an anchor point. Add that to the list. So then should be able to still rotate it around. There you go. Let's reset this a little bit. So now you can see that this one's locked in place. And if I move it, everything else should adjust accordingly. I'll still maintain that position. So let's turn some of this off. So you can see how you can start to use constraints to then build a relatively constrained model. If I wanted to play around with, say, dimensions as well, I could add maybe a length constraint to one of these sides. You can take one of these segments. Let me turn my bifocals on for you guys. So I can take one of these lines, let's say this bottom one. That's a length of, let's say 40. I'd like to maintain some length even if we shift these things around. See if I can get it to move again. So you can see this one changes everything else, but this one line still stays the same length. So we can set up as many constraints as we want as long as it doesn't become over constrained. If we put too many constraints where there's not a possible solution, then it'll have trouble trying to figure it out. So if we set a length for all of them, maybe those don't add up. Or if we set just one of these angles to 45 degrees and the other ones to be 90, then those sort of things might not work. Or if we were to set lengths that don't sort of resolve themselves in a 90-degree shape. So you can set too many constraints, and that might break your script. So as long as there's enough things that there are variations, it should be happy enough to play around with these. So that's interesting. You could think of how you could use that for potentially creating floor plans or providing some sort of constraints to, say, square footage or orientation as you're moving things around. That could be useful in an architectural context. So I think that's it.